We are diving right in today with a quantum autopsy of something you literally interact with every single day. You've seen it a million times, right? Sticking a note to the fridge, picking up a heavy weight at the gym, snapping your tablet cover shut. It feels kind of like magic, this invisible force just reaching across empty space, pulling and pushing with all this incredible power. But in this explainer, we're going to crack open that illusion and see the absolute strangeness operating underneath.
Because that perfectly simple explanation you were handed when you were, 12? Yeah, it's dead on arrival. It is a complete fabrication that masks one of the most bizarre and frankly fascinating mechanisms in the entire universe.
You probably remember hearing this exact phrase, opposite poles attract while like poles repel. It's a nice, neat little package, isn't it? But here's the thing, it explains absolutely nothing about reality. It's a purely surface-level description of an effect, not a cause. To really understand magnetism, we have to toss this middle school crutch right out the window and zoom way, way down.
Part 1. The guts, zooming in to quantum spin.
So to get how this works, we have to rip the casing off and head straight down to the quantum level. And down here, we find this incredibly bizarre property called spin. Now, if you picture a little 3D stick figure furiously trying to spin a top, you've got the classical idea. But at the quantum level, electrons aren't little spheres spinning on an axis. They literally do not physically rotate at all. Yet, they somehow possess this intrinsic angular momentum, much like they possess a negative charge. And because of this non-spinning spin, plus their charge, every single electron generates its own miniature magnetic field. They act as tiny, fundamental magnets.
The absolutely crucial piece of the puzzle here is how these tiny electron magnets interact with each other. In atoms that have unpaired electrons, quantum mechanics dictates exactly how they align. If electrons have parallel spins, meaning they point in the same direction, their wave functions interact in this highly specific way that actually allows them to stay slightly farther apart. This reduces their electrostatic repulsion, which keeps them in a lower energy state. Now, if they have anti-parallel spins, they overlap more closely, and that pumps up the repulsion and raises the energy. And nature absolutely hates high energy, so it heavily favors keeping those spins parallel.
But look, just having parallel spins inside a single atom doesn't automatically make a chunk of metal stick to your fridge. I mean, why is iron highly magnetic, but manganese, which actually has even more unpaired electrons, is totally useless as a magnet? Well, it all comes down to a little thing called exchange interactions. This is a super subtle quantum force where the wave functions of neighboring atoms overlap. In lazy metals like iron, cobalt, and nickel, their specific atomic lattice structure literally coerces these adjacent atoms into aligning their spins parallel to one another. They form these massive synchronized groups called magnetic domains. Manganese, on the flip side, has a structure that forces its adjacent atoms to align in opposing, anti-parallel patterns. It just cancels the magnetic effect out entirely. But iron forces them all to march in the exact same direction.
Part 2. The ghosts, virtual photons, and QED. Okay, so we've got our aligned spins, but how do they actually reach across empty space to pull another piece of metal? Welcome to the deep, slightly terrifying waters of quantum electrodynamics. As it turns out, the vacuum of empty space is actually absolutely teeming with quantum fluctuations. We're talking about virtual photons. And no, these aren't the regular photons making up the light illuminating your screen right now. These are ghost particles. They pop in and out of existence so briefly that they literally cannot be measured. They exist for one sole purpose, to act as messengers between charged particles.
Let's break down what I like to call this bizarre invisible boomerang protocol. Just picture two people sitting in small boats on a lake. If they throw really heavy medicine balls back and forth through each other, the recoil pushes their boats apart, right? That is exactly how virtual photons mediate magnetic repulsion. Now imagine those exact same two people throwing invisible boomerangs that loop around and pull them closer together when they catch them. Boom, that's magnetic attraction. It is this completely unmeasurable, frantic game of catch happening billions of times a second across the total void of space. So why do these particles even participate in this crazy invisible boomerang protocol to begin with? Well, it's because they have an electrical charge. But if you're wondering what exactly a charge actually is, the terrifying truth is, we don't know. Seriously, physics knows exactly how charge works through the exchange of these virtual photons, but we have absolutely zero idea why the property of charge exists at all. It's just a fundamental brute fact of the universe.
Part 3. The motive, wave functions, and the lazy universe.
All right, so we know the how, but why do these magnets physically rush toward each other? To understand their motive, we have to look at the ultimate driver of physics. The universe is incredibly lazy. The strings here are actually being pulled by the Pauli exclusion principle. Because fundamental particles are essentially just waves defined by the Schrödinger equation, their probability of overlapping in the exact same state is absolute zero. Two identical electrons simply cannot occupy the exact same space and state at the exact same time. Period. This principle is the unbending law of quantum real estate. Let's dissect the ultimate truth of what you actually feel in your hands. When you force two north poles together, their electron spins are aligned in these opposing, clashing ways relative to each other. Their wave functions literally interfere destructively. And this creates a highly unfavorable, high-energy state in the space right between them. As we established, the universe hates high energy. Pushing them together is quite literally like pushing a boulder up a steep hill. It takes real work, and the materials violently push away to avoid that overlapping state. But flip it around. Bring opposite poles together and the spins align smoothly. Their wave functions overlap constructively, which drops the combined quantum energy down to a much lower, more stable state. The magnets aren't magically drawn to each other. They are just rolling down a quantum hill. They're spontaneously falling right into the path of least resistance.
So let's deliver the final coroner's report on magnetism, bringing all of this together. We can wrap all of these intrinsic spins, boomerangs, and interfering waves into one incredibly cohesive, mind-bending reality for this explainer. Electrons have a quantum property called spin that turns them into tiny magnets. In certain metals, exchange interactions basically bully these spins into aligning perfectly. These aligned domains then scream out their electromagnetic force by throwing those unmeasurable virtual ghost photons back and forth. And finally, the physical push and pull you feel, that is simply the universe being incredibly lazy, shifting these wave functions around to constantly seek the absolute lowest possible energy state.
Magnets aren't magic. Not even close. They are just the macro-level evidence of a frantic, invisible quantum dance happening right in the palms of your hands. Which leaves us with this final, honestly rather provocative thought. If the very forces that hold our physical reality together are mediated by unmeasurable ghost particles popping in and out of the vacuum of space, what else is surrounding us right now that we simply can't see? Just keep that in mind the next time you stick a grocery list to your fridge.